Hello, and welcome to today's problem 33, search and rotated sorted array. So you're given an integer array nums sorted in ascending order with distinct values, and before being passed to our method, nums is rotated at a certain unknown pivot index, such that the results will have let's say we have this example over here, 0, 1, 2, 4, 5, 6, 7. It could possibly be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Given this array nums, after a possible rotation and an integer target, you want to return the index of the target if it's in the nums or -1 if it's not, and we want to do this with an O of log n runtime complexity. We're given a few examples here. We have 4, 5, 6, 7, 0, 1, 2. We have a target of 0, and we return 4 because that's the index at which the 0 value is. Same thing for these ones. We have a target 3 here. It's not in the array at all, so we return -1, and same thing with the final example. We return -1 because it's not there. Okay, let's go ahead and take a look at this example over here so we can make a little comments about it. Okay, so taking a look at the problem statements, since we have to write it in O of log n time complexity, and also the array nums is sorted in ascending order, this gives us a hint that we may have to use binary search in order to do this problem. Now, a regular binary search with a left and right pointer won't work because it's pivoted. So if it's pivoted, then if you take the middle, it's not necessarily a guarantee that all the values at the very left or less than, and all the values at the very right are greater than the middle pointer. So we're going to have to think of another way to do this. If we take a look at this array here, we can see, because it's rotated, there's two different portions of the array. We have the right portion over here, where it's 0, 1, 2, the one that's been shifted, and then we have the left portion over here, where it's 4, 5, 6, and 7, so the left portion over here. So in order to be able to determine whether or not a the middle pointer that you're currently at, the number that you're currently at, is part of the left portion and the right portion, we need to figure out some sort of condition in order to be able to see. So one thing we can do is we can take a look at the middle value over here, 7, and we can see that for let's say nums at mid, the current value that we're on, we take a look and we see, is it greater than the very left value that you're currently at? So we can see maybe if nums left is less than or equal to the current middle value, that means that you're currently within that left portion of the array because it's less than. For example, if nums mid arbitrarily is at the 0 value over here, then if we do this check, we can tell that obviously 4 the left is greater than the middle one. So that means that you're on the right portion of the array over here. So go ahead and keep that in mind as we're tackling this problem. We have a way of differentiating between the left and right portion of the array. Now, for the left portion of the array, what do we want to do? Left portion. Well, we want to search for the target, right? So in order to search for the target at the left portion, we need to take a look at what we're looking for. So we know we have the middle pointer over here, right? So we take in the middle and we're at 7 currently. We're looking to see the values from the left to the middle and the right. That's what we have. What we can do is we can check to see if the nums left, right, if it's greater than nums at the left, right, and nums, if the target is greater than nums to the left, and for nums left, for the nums middle, if it's less than the target, then we know that it's at the right, that it's at the left portion. The target is within the left portion, and we have to search within that area. So we can keep that in mind. And likewise, if it's the other way around, then it's within the right portion of the array. So let's say if otherwise, right? Otherwise, nums right. Well, otherwise we have nums left check to see whether or not if that's less than the target, or the nums at the mid. If the element is greater than nums mid, right? If it's greater than target, then that means it's within the right portion. So yeah, we can keep these criteria in mind, and basically we can check to see whether or not the current target value is in the left portion of the array. If the target is less than the number at the very left pointer, or greater than the element at the very right over here. So let's say like for this example, we're looking for 0. We can check to see, is it less than 4, and is it greater than 7? Well, it's like not greater than 7, but it's less than 4. So therefore, it has to be in the right portion of the array. Now, what do we need to do if the element is not in the left portion? We have to do a binary search, right? As part of the binary search, we have to move the left pointer to negate and not search all these values, because it can't be any of those values. So what we have to do is we can set the left pointer here, left equal the mid plus 1, like the m plus 1 over here. So we'll move this over here, and it'll be m plus 1. So it has to be within this range. And then we can rinse and repeat for the same again. Otherwise, also we have to take a thought at the other possible condition over here. If, let's say like over here, let's change this convention. Okay, so for here, otherwise, if it's not here, then it must be in the right portion, right? We should probably check the right portion as well. So, like if the current mid value, right? Let's say arbitrarily now, we have the left pointer here, the right pointer here, and the mid value, let's just say it's at like 1 or something, right? Or okay, like if we leave off at where we were before, over here, yeah. So like left plus, yeah, all plus r divided by 2. We reset it so it'll equal 1. It'll check the middle of that again. We'll go ahead and take a look at this value now. So if the current value, for this one, the left pointer 0, it's if we take a look at that versus the middle value, right? Less than or equal to the mid value. Well, we take a look at this, and yeah, okay. Sorry. Okay. So yeah. Okay. Let's just assume a scenario where like the mid pointer is over there and the left pointer is back over here again. So if we take a look at this again, what we also need to do is determine like whether or not it's within this portion of the array. And how do we determine if it's within a portion of the array? Well, we can check to see if nums, let's see like the right pointer, right? If nums right pointer is less than the target and the nums mid is greater, right? If nums mid, right, is yeah, okay. So if nums r is greater than the target and nums mid, right, is less than the target or greater than the target over here, and yeah, for this and this, right, we have nums right less than the target and nums mid greater than the target. If this is fulfilled, right, well, if this or this is fulfilled, right, then that means that it's within the, that is not within that portion of the array, right? So that means like, let's say like we check the target, we check the very right value over here, let's say like 2 over here, and we take a look and see, right? We take a look and see 2, and check to see whether or not that is less than the target. And let's say the target is 0, right? Is 2 less than 0? No, it's not. We check to see the middle target over here. Check to see whether or not that's greater than target. And basically, we can do the opposite of what we were doing for the left portion of the array here. So if this is true, then you want to set the right to equal the mid minus 1 over here. And likewise with this one, if let's say like in the scenario where you're in the left portion of the array, you have to be able to check like basically like the opposite portion, right? So you have to do r equals mid plus 1 over here. Okay, so and same thing for this one, you have to check to see whether or not the left is equal to mid plus 1. So yeah, like this way you'll be able to determine like whether or not like the target value is at a given portion or not. And at the very end, if you can't find anything, what we can then do is just return -1. So yeah, and the whole time, every single iteration of this, we'll also want to check to see whether or not it's equal to mid. So just to run through this example one more time, make it a little bit more clear, we have the left pointer over here for the right pointer over here. We start off at our middle, m is equal to 7. We take a look and we check, is the left less than or equal to the nums mid, right? Like what part of the thing is it on? Well, we see that obviously 7 is greater than 4, so that means we're within the left portion. So we check to see, once we're in the left portion, we want to see if it's within this range, right? Is the target 0 greater than 7, or is it less than 4? Well, it's less than 4, so it has to be in the right portion. So what we then do is we set the left equal to mid plus 1, and then we basically move forward in the iteration. And then for next time again, we set the middle to equal to the left, right? 0, 1, 2, 3, 4. So 4 plus 5 is 6. That's 10. Divided by 2, that's 5. 0, 1, 2, 3, 4, 5. The mid is then equal to 1 over here. With this mid pointer over at 1, what we can then do is check to see whether or not the target is equal to mid. Well, no, it's not. It's 1. So then we next thing we do is we check to see whether or not the number at the left pointer is less than or equal to num as the mid. It is. So therefore, that means we're basically that means we're at the right portion, the left portion of the array. So, well, this new left portion is because it's like sorted already. So from here, what we do is we check to see whether or not from here the target is within the range, right? So it is. So if this is, then we set the right to equal the mid plus 1. So we set r over here. So we set the right to equal the mid over here -1, right? So L and R, and then we go ahead and do like the check again. We basically go ahead and do another check, and we check to see whether or not the target at nums mid again is equal to that value. Well, it's 0. So from there, then you return the value in over log n time. So if we go ahead and begin coding this up now, we check to see basically left and the right. We can set that to 0 and length of nums subtracted by 1. Right, so we set those pointers from the left and the right, and then we check while left is less than or equal to the right, we can check to see what the mid is. So mid is equal to left plus right. We divide that by 2 in order to get the mid, and then we can check to see whether or not the target, if target is equal to nums at mid. If so, then we want to return mid. Otherwise, we want to check the left sorted portion, check left, and then we do that by following this criteria here. If nums left is less than or equal to nums mid, we can go ahead and check to see if target is less than nums left or target is greater than nums mid. We can do left to equal the mid plus 1, and otherwise, like we said before, we want to switch the opposite for r to equal mid plus 1. So r equals mid, or like mid minus 1 actually, because of the nature of it being 0 indexed. So we'll go ahead and do that over here. Now, if all of this, basically if it's not left is less than or equal to the right one, what we can do is we know that it's in the right sorted portion, right? Right sorted portion. We can then check again to see if target is less than nums mid, right? Over here, target is less than nums mid. If so, or if the target at nums right, if it's greater than the target at nums right over here, right? If so, then we set the right equal to mid minus 1. Otherwise, what we do is we set the left equal to mid plus 1. And then at the very end, it'll keep iterating through. And then if we haven't found anything at the very end, what we want to do is return minus 1 over here. So we'll go ahead and do that over here. Take a look at this again. Okay, so if we go ahead and run this now. Okay, we have accepted. Go ahead and fully submit this. Check to see. There we go. Accepted. Thanks for watching.